Okay, in a nutshell, I'm going to try and show what I've really come to after a year and a half of Grasshopper and what I want to do with it. So this solid is formed, and it's formed from a surface, and that surface is formed from a curve, and that curve is formed from a point. And really, that's what it's all about. It's also not about doing anything within Rhino, so you can take your visibility and get rid of this object. And let's just jump into shaded and start with nothing. And let's see what really goes into making this script. It really begins with thinking about how I would make a point. And the best way to make a point is probably take a point, put it in here, grab it, and set one point to that. When you do this on points, sometimes online, you just make that point. There you go. You have your ghosted point. So I can get rid of these other two. Get rid of this one. At least I should be able to get rid of that one. And that as a point has been internalized to that data. I can move it around. Whenever I move that point's made. And here it is again as I internalize it and internalize that data. And then there's the point at x, 1, y, 4 point whatever, and 0, z. And of course, if I change that point when it's been extracted, when I start to take that point and move it around, then obviously I change the data that's here. So as I move that, you can see it changing the data. That's the easiest way to start with a point, because this is really how to make point generators. But that's dependent on something in Rhino, which I'm not very excited about. So I will internalize that point and make it so I'm not dependent upon anything. And the point in the script holds the geometry in it. I don't deal well with containers. I mean, I do, but I don't really find them that wonderful. The best way to make a point would be to construct a point. And you construct a point by number sliders. So once again, we've got a point, we've got a number slider, we've got data in a panel, and as I play with here, you can also see that point move in the Rhino window, ghosted in the Rhino window, XYZ. Another great way to make a point. But let's make it more. You'll notice the single data wire here is not a double wire like we're going to have down here, because now we're dealing in lists of points. So the best way to make a list of points is definitely generate a point the exact same way you had. But you're going to see here I have grafted points. You can tell by the way, actually that's a list of points, not grafted yet. And what I do is I take a range, I have a domain feed into that range, and I have a start of the domain and end of that domain. I also have a step count of how often I'd like to, and of course you can't visualize until you bring it into a point. So if I make within here more point counts, you see more points get in there, so you get more whatever that's called. I can't remember. Clarity on the line if you're going to do something with those points. You can also take those points and change them. You can start them in a different spot as well. But that's a great way to make points and make lists of points. That again, I could do again, and I could do it through a series. The series is a little different. You'll see here, the series is a little larger because we're not dealing with a domain of 0 to 1. We're dealing with a start point of 1, a step of 1, and actually a start point of 12, I think. So, and if I do this, I can actually take that up. Well, where's my start point? Ooh, yeah, 13. I think. No, my start point starts with the domain, and it'll default to 1. I could actually plug that start into 1, and then you'd see where it actually starts there. And then you got a step of 1, and you've got how many are there? 13. So another way to get a list of points, and there they are. Now, I do want to change them back to kind of where they were because I was happy with what that script was. And what I'll do through that is say, okay, we're done with the points. We don't need to visualize the point anymore. Turn the points off. Then let's go in and say, okay, well, how can we make a curve, curves from those points? Well, you can take the base point and put on a center box, and that's in the solid tools. And that's another thing. That's kind of like bringing in points out of Rhino. It's almost, for me, almost seems not right to have to go to surfaces and find these primitives. I should be able to create them. But needless to say, I put that primitive on there only so I could populate a 3D of points. And there's a seed tool here, which allows me to go back to the same seed, but I can generate any array of points I want as I do that. And as I do that, which is kind of nice, I can take that and interpolate that curve. And now I have pretty good control over a variety of curves. And they're pretty chaotic, so I'm going to stop the script at this point when I get into that. And you can open it up and you can close it by using periodic as a Boolean toggle. And you can change your size and square of that box to change that as well. It doesn't have to be uniform. You could do, it's like a scaling uniform, or you could do you could put a different slider to each one of those XYZ. But I'm not going to go farther with that curve script because there's really no point in trying to take that into a surface right now. It's too crazy for me. So what I do is I have another script and I take a point And I say, well, let's take it and run it through some polynomials, or sine and cosine functions in the xyz. So I took my points and I deconstructed the points that were coming out of here. This point was a nice set of points, so I deconstructed it so I could get it xyz, so I could manipulate each of xyz. Manipulate this one with sine, and I have an amplifier on here. So when I do that, I go from those initial points here, and I pump them into this bigger point system here, and I interpolate that. I have a pretty smooth little curve there, which is fun, but it's kind of boring. I find that it's cosine and sine is not that exciting. So what I do is I do it again down here, and I say, well, let's do it with a what was the big change in here? Well, I was dealing with a series. If you go back, I was dealing with a series as opposed to a range. So it was a little bigger curve when I was dealing with it. So if I deal with bigger data, doing fancier things, as you can see, then as I bring that into sine, it's going to have a totally other effect, the same script. So one there in a range, one there in a series. Now that's the series that I want to continue and go to a surface generating script. So I'm going to pipe that curve. And I know a pipe is a surface, not capped, it's just a surface. And I can look at it and deconstruct it and look at it as a surface. Now if I take a section of that surface, let's say 0.5 to 0.5 on a V count, I just get a little section on it, which is really nice. Now I can take more or less of that curve if I want to. That's kind of like how that curve is created. Very nice to do with a sphere too. But let's just put it at 0.5. And you'll notice I reparametrize the curve. I have to make the surface from 1 to 1 for this to have an effect. Otherwise, it'll have this little microscopic effect in the back corner. I divide that surface up, and you'll see that in the UV count, it goes in different directions. And then basically, I have 10 set to the U and 10 set to the V, and I'm moving it out from it. So I have my initial points here and my outer points here. And without dealing with lines and lofting and all this crazy stuff that you can do, I'd rather just deal with points. It keeps my scripts incredibly fast. As you can tell, there's nothing on here with a profiler yet. I don't think there's any profiler data on any of this, which tells me the script is pretty darn fast. I'm not sure why I have all this other stuff up here, but I do. I just want to get rid of that stuff that's left over from our jewelers. But basically, I'm going to take those. I'm going to move them in another direction from here to these points, move those points, and then I'm left with really all I did very quickly was make this surface. So I took that, it became a surface as soon as I piped it. So really that was the surface generation, and now it's just surface manipulation, which has been kind of fun. And once I get to a surface manipulation of what I want, let's say this geometry here, and I make a surface from points, I'm still dealing in a surface at the beginning of the script, a bigger surface than what I had back here, a smaller one and a bigger one. But now I see the potential for analyzing these two surfaces and making a solid, because I understand that solids are not solid, they're hollow and their surfaces on the outside. So here we go. They're just watertight. So to make it watertight, I take a B rep of this side, a B rep of this side, and I take, I'll show you the edges and surface, there they are, and I take my list items, and there they are, 1, 2, 3, 4 on one, and 1, 2, 3, 4 on the other. I separate them, join I to I, 1 to 1, 2 to 2, and 3 to 3, which is basically I plus 1, I plus 2, I plus 3, and then repeat it down here, and you get this that nice surface, that nice surface, that nice surface, and that nice surface, and I'm left with a beautiful form. And that baked is pretty delicious, and you've already seen what that is, and it's this form right here, and pretty nice if you think about how that was made in 8 minutes. Many different scripts, but I have my preferences as I move into solids and surfaces. But where my mind is way back here and dealing with what it really means to inform and make points. And once I know how to do point generated scripts, I can go into curve generated scripts, surface generated scripts that work best for me, and solid generator extrusions and things like that. There's so many options, but if you can get the point, you will definitely make some beautiful, understandable scripts and own your geometry. And now in this window back to CAD, you can play with size, scale, geometries, and believe me, it's baked, so there's no reason not to go in here, Control Shift, edit a surface, pull that one out, and you can see I can start to take that whole thing apart and analyze that. I can find the length on here, I can ribbon these tools, I can do whatever I want. A very nice script to dissect and take it apart. Things I would never generate perfectly in Rhino, but I certainly can produce them perfectly in programming and math and algorithms, and then you're back into the CAD program of what you're going to do. Thanks very much for watching.